As usual in the Smith's textbook, the questions are extremely good because they kind of guide you in a way of how to think correctly about these things. We're supposed to identify the alkyl halide and nucleophile and determine which mechanism occurs, then determine which solvents afford the faster reaction. Okay? So what we're looking at is first the alkyl halide. We identify the alpha carbon, and then what we need to do is count carbons attached to the alpha carbon. Again, the alpha carbon is the one that's attached to the leaving group, okay? So the purple dotted carbon is the alpha carbon. It's connected to 3, so we would say that this is a tertiary alkyl halide, okay? A tertiary alkyl halide is always going to react by SN1, okay? I don't need to look at the nucleophile to make that assessment. I just know there's only one choice. That's it. Now I need to think about, what solvent favors SN1? The solvent that favors SN1 is going to be your polar protic solvents. Okay? The polar protic solvent here is CH3OH because it contains an OH bond. Now, what is this thing DMSO? All of your polar aprotic solvents are going to be your alphabet soup abbreviated things, okay? So keep that in mind. You don't need to memorize them, I don't think. Depends on your professor. But polar aprotic solvents are going to be your, DMSO, DMF, HMPA. They might have a Lewis structure if it's small enough to write out, something like that. They have these weird letters, okay, that stand for the solvent. So let's highlight the answer that we've selected for part A, the polar protic solvent. All right. The next molecule, part B, we have the alpha carbon, and we want to count carbons, and we see, that's primary. There's only one carbon attached. So primary alkyl halides, have only one choice. They react by SN2. The sterics is such that we could kick that off easily. We can't ever form primary carbocations. So, what solvent favors SN2? That's going to be the polar aprotic solvents. Okay? Polar aprotic solvents have no OH or NH bonds, and that's going to be, we have to guess, a DMF. You could look up what that is if you're really curious, but the solvent here of choice is going to be DMF, okay? They're going to have the weird lettered abbreviations, okay? So yeah, that's the answer there, DMF, okay? That's a solvent. In part C, it's a little more tricky. Let me explain why. So again, we identify the halogen, the leaving group. We identify the alpha carbon. We count carbons attached to the alpha carbon, and we come to the conclusion that this is a secondary alkyl halide. Okay? Secondary alkyl halides can react by SN1 or SN2. Okay? So how do we know which it is? We then have to look at the nucleophile. Okay? And they suggested in the word problem to look at the nucleophile. Okay? When we look at the nucleophile, we see that we have a strong nucleophile. We can say that because it has a negative charge. Okay? So CH3O minus is called methoxide. That's a strong nucleophile. And strong nucleophiles favor SN2. And so we're going to cross out SN1 here as a choice and say, okay, we know this is going to be SN2. Now we go back to our idea that SN2 reactions are favored or promoted by polar aprotic solvents. Okay, polar aprotic. Now you can see that that has an OH bond. That's definitely protic. And your alphabet soup solvent, HMPA, is the one that's going to be polar aprotic. Okay? Thanks for watching. I hope I helped you figure out some of these complicated problems.